Hello and welcome. In this video, I'm going to be solving this problem, and the question is to find the acceleration of this system. Looking at this, we have a mass of 20 kg, a block of 20 kg, and we have a block of 30 kg, and we have a pulley system, and we also have an inclined plane at angle 30 to the horizontal. Okay, so because this is 30 kg, the movement will be in this direction. Because this is mass 30 kg and this is mass 20 kg. 30 kg is larger than 30 kg, so the acceleration will tend to go in this direction, in the direction of the larger mass. So whenever we have two masses like this, acceleration is always in the direction of the larger mass. If this block were to be 30 kg and this block 20 kg, acceleration will go in this direction. The movement will be towards the larger mass. And so this is how we approach. That's first thing to take note of. The acceleration is always in the direction of the larger mass. Alright. So the block 30 kg will have a weight which will act downwards. Its weight will be equal to mass times the acceleration due to gravity. Let's take our acceleration due to gravity as 10 and our mass as 30 kg. We have this as 30 times 10, which is 300 Newton. And this is the weight of this block. Now, for every inclined plane, there is always a component, a force component that will act in this direction. In this case now, it will oppose the motion of the tension in the string. Now the first component in this direction will be W sine theta. And in previous videos, I've actually explained why this is W sine theta. So I'll just leave the links in the description below for you to check that out. Now we have, let's consider block 20 kg. Now the movement of this block is in this direction, the acceleration of this block. So this string is being pulled in the direction of the 30 kg mass, and so the tension will be greater than this force component. Likewise, if we look at the 30 kg mass, this mass is being pulled down in this direction, and the acceleration is downwards. In this direction, the body is moving downwards, and so the weight will be greater than the tension. Okay, so let's take it step by step. When we come here to this 20 kg mass, we're simply going to follow this law, this Newton's law, that total force is mass times acceleration. Now, because the tension is greater than the force component, our total force will be the tension minus this force component, W sine theta, and it will be equal to mass times acceleration. And so we have our tension minus our weight sine our theta is 30 degrees, and our mass is, maybe let's just substitute the weight directly now. So our weight will be mass of 20 kg multiplied by acceleration due to gravity. So this will be 20 times 10 sine theta, and it will be 200 sine theta. So this component will be 200 sine theta. And here we have our mass 20A. So let's take this as equation 1. Now coming to the 30 kg block, we'll follow the same formula. Total force is mass times acceleration. Because the block is going in this direction, the weight will be greater than the tension, and so we're going to have it as the weight minus the tension to be equal to mass times acceleration. Here the weight is 300 Newton, so 300 minus T is equal to mass, which is 30 times acceleration. So let's have this. Our theta is 30 degrees, so 200 sine 30. When you type that in your calculator, let me type that in my calculator. I have this to be 100. Okay, so I have t minus 100 is equal to 20a. And so let me solve this equation, t minus 100 equals to 20a, and this equation 300 minus t equals to 30a simultaneously. So to write it in a similar pattern, let's write it as t minus 100 equals to 20a, and let's rewrite this as minus t plus 300 equals to 30a. Looks similar, right? So now we can add equations 1 and 2 to eliminate the tension. So t plus minus t is 0, minus 100 plus 300 is plus 200, and this is equal to 20 plus 30, 20a plus 30a, which is 50a. And we can arrive at the conclusion that our acceleration is 200 divided by 50. 0 comes to 0, and this is 4. Let me just write it. Let me write it here. 4 meters per second squared. And that is how we approach this question. Thank you very much for watching. Don't forget to like, share, subscribe, leave a comment, and click on the video you're seeing on the screen right now.